Hello. In this lesson, we will talk about a property of matter called volume. You may remember that scientists define matter as anything that has mass and volume. In our previous lesson, we have talked about mass as the amount of stuff or the amount of matter in an object. Let's look at what volume means. Volume is the amount of space an object takes up. You guys may remember looking at these three bottles in class. If we look at the first bottle right here, which is filled with cotton balls, and if I was to put this bottle on the triple beam balance to measure its mass, the mass of this bottle is very less compared to the mass of the other two bottles. One of these is filled with iron nails, the other one is filled with water. So the mass, the amount of stuff each one of these bottles that is carrying is very different. However, if I was to put one of these water bottles in my backpack, no matter which bottle I pick up, each one of these will occupy the same space. So I can say that these bottles have the same volume. They take up the same amount of space. We said that anything that has mass and volume is matter, which means all solids, liquids, and gases have mass and volume. We will look at how to measure the volume of solids in this lesson. So, looking at this picture, I have a regular object. A regular object is one which I can easily measure the length, width, or other dimensions of. Right now, for this cube, I can measure the length of this cube. I can do a linear measurement for the width of this cube, and I can measure the height of this cube using a ruler. I can then use a mathematical formula to find out the volume of this cube. So the formula I use is volume equals length times width times height. A mathematical formula is basically a representation in symbols. So if I say the length is 3 meters, I say the width is 2 meters, and I measure the height as 5 meters, I will multiply these three terms, length, width, and height, to find out the volume of this cube. And the unit I will use to define the volume of this cube is cubic meters, because I am multiplying three linear dimensions. So I've multiplied the number part, the numeric part, 3 times 2 times 5, and I get 30. And I multiply meters times meters times meters to get meter cube or cubic meters. Here are two more examples of finding the volume of a regular object using the formula length times width times height. If you notice here, the unit that I'm using to measure the linear dimensions is centimeters, and in this case my volume would be centimeters times centimeters times centimeters, or centimeters cubed, or I could read it as cubic centimeters. Let's look at how we measure the volume of irregular objects. Irregular object is an object that does not have a symmetry, or an object that does not have an even shape. So if you remember, in the science lab, we have used a couple of different tools to measure the volume of irregular objects. We can use these long cylindrical tubes that are called the graduated cylinders. And we noticed that graduated cylinders come in different sizes. We also looked at why beakers would not be a very accurate measurement tool. And we also used the displacement can or overflow can to measure the volume of irregular objects that wouldn't fit into the graduated cylinder. So to measure the volume of irregular objects, we use the water displacement method. The movement of water is known as displacement. So if I have an object, for example, if I have this dinosaur and I want to measure the volume of this dinosaur, I could take some water in the graduated cylinder. I would record how much water I have taken, so that would be my starting volume. I know that when I drop the dinosaur in the graduated cylinder, the water level will rise because this dinosaur is taking some space. It is matter. It is taking some space in the graduated cylinder. It will displace, it will move the already existing water in the tube, and hence the water level goes up. I will record the final volume of water. I would subtract the initial or the starting volume from the final volume, and the difference represents the volume of the object. Lastly, let's look at measuring the volume of an irregular object using a displacement can or an overflow can. If an object is too big to fit into a graduated cylinder, we use a displacement can. And how the displacement can works is simply you fill up the water up to the top, let all the water drain. Once all the water is drained out, I empty my beaker or graduated cylinder. I gently put the object in, and once the object is in the displacement can, it will displace the water, it will take up space, so some of the water will come out of the spout. The amount of water that comes out is the same as the volume of the object. So I will then measure the volume of water that is collected either in a beaker or in a graduated cylinder, and that's the volume of my irregular object that I placed in the displacement can or the overflow can. So you guys remember our human displacement lab to measure your volume? And the volume that we measured here when we collected the water was in liters. So volume of solids can be measured in cubic centimeters or cubic meters, or we have bigger or smaller units depending on the size of the object. Volume of liquids is most commonly measured in liters or milliliters.